This is Andrew. He is a 24-year-old graduate student at SFU. He recently bought his own car and is unfamiliar with most roads, so he bought a GPS to help him find the most efficient routes to his destination. Today, Andrew has just finished some research work at the Surrey campus and needs to attend a conference in Vancouver. Andrew has a Garmin GPS attached to his windshield using a stand. However, it is placed at a distance, so he has to lean forward to reach it. Occasionally, he has to press multiple times due to touchscreen insensitivity. When inputting the address, Andrew has to put the city, unit number, street before reaching the final confirmation screen. Not only is this a lengthy process for a simple task, a small mistake would result in having to start the whole process again. On top of physical constraints and poor interface for address input, there are some other problems with the GPS. After he confirms the address, it automatically suggests a route for Andrew that he cannot change. This limits user control and makes it unable for him to avoid things such as traffic jams or accidents. Andrew also cannot zoom in and out of the map, which limits his understanding of the overall route he will be taking. With the GPS located at a distance, Andrew cannot see the street names clearly at a glance, and trying to understand the GPS may result in distracting Andrew, creating a hazard for both him and other road users. To counter these problems, our redesign objective is to embed the GPS system into the car. By integrating ergonomics into our design, we aim for the GPS system to be less distracting to our users while keeping the interaction as simple as possible. With this redesign objective in mind, we created two prototypes that aim to solve the problems of the Garmin GPS. Prototype A is an embedded GPS system in the dashboard of the car, where most drivers are used to looking at already for information such as the speed. By positioning the GPS there, distraction is minimized as users will not have to look at multiple places for information while they are driving. To input the address, the user can connect their smartphones via Bluetooth and directly send an address from their phones to the GPS system, where it then confirms the address by allowing users to select a preferred route. Buttons are also designed onto the wheel of the car so that users can interact with the GPS easily just by using their thumb. Prototype B is also embedded into the car and uses the same method of inputting the address through a smartphone. The difference is that Prototype B is a projection of the GPS information onto the windshield area. Users can then interact with it through gestures such as tapping and swiping. When driving, directions and street names will be displayed on the lower third of the windshield, as if it is projected onto the street itself. The map information remains on the side as a reference for the user if they wish to look at the overall route or additional information. Also, if there are any changes such as low gas level, the user receives a prompt on the side to add a detour into the original route. From our evaluations of the two prototypes, we gathered both quantitative and qualitative results. The quantitative results showed that Prototype A was less prone to errors out of the two, yet Prototype B had fewer delays in response time. Almost everyone was able to complete all the tasks in both prototypes, but subjects asked the facilitator more questions while testing Prototype B. Our qualitative data gathered from both observations and questionnaires shows that while some subjects thought Prototype B was distracting the drivers, the instructions were more clear and they were able to react quicker. Some subjects had difficulty understanding how the gestural motions worked and felt that the buttons were easy to press while driving. However, when asked which one they preferred, most subjects liked Prototype B because the information is displayed directly within their line of sight. They think that as long as the distraction is further minimized, it will be cool and futuristic, at the same time functional.